In Module 3, we will be discussing the topics analytic function of complex variables, Cauchy-Riemann equations, harmonic function, Euler's formula, and application of Euler's formula in representing summation of series. Complex numbers were introduced when mathematicians tried to solve the equation x square plus 1 equals 0. We obtain x square equals minus 1, wherein we have the equation x equals root of negative 1. It was Euler who represented root of negative 1 by I and I square equals minus 1. It was mathematician Gauss who gave the representation z equals x plus iy is the general form of a complex variable z. Let us try to discuss limit of a complex function. Suppose f of z is a complex function defined in terms of a complex variable z, and we represent f of z by w. Then we say that f of z approach limit L when z approach z0 if we have for every real number epsilon greater than 0 there is a positive real number delta greater than 0 such that modulus of f of z minus L is less than epsilon whenever modulus of z minus z0 less than delta. Whenever we make a study on complex function, we have to make use of two copies of complex plane. One is z plane and the other is w plane. Z plane has real axis x and imaginary axis y, whereas w plane has real axis u and imaginary axis v, just by notation. Suppose we have a disk of radius delta centered at z0 lying in the z plane, and this disk is obtained as a collection of points lying in the neighborhood of z0. Similarly, we have a disk in the w plane which is centered at L and is of radius epsilon. The disk is a collection of points which are lying in the neighborhood of L. We say that the complex function f of z approaches limit L if for every arbitrary point z in the disk of radius delta centered at z0 has f of z lying in the disk of radius epsilon which lies in the w plane centered at L. That is, for every arbitrary z in this disk, we can find an f of z value correspondingly in the disk which is located in the w plane. Symbolically, we write limit z tends to z0 f of z equals L. If you consider w equals f of z as a machine, then z plane stores the input and w plane stores the output. Z plane constitutes the domain of w equals f of z and w plane constitutes the codomain of w equals f of z. There is a major difference in definition of limit in real case and complex case. In real case, we have an arbitrary real valued number x approaches x0 only in two directions, either from the left side or from the right side. And that's why we have the concept of left hand limit and right hand limit. But in case of complex numbers, there is no left and right direction possible. There are infinitely many directions along which the limit point L can be approached by a complex function f of z. In case of real numbers, we have the definition of limit along a line, but in case of complex numbers, we have the complex number z approaching z0 from infinitely many directions. And if f of z assumes L as z approaches z0 through any path, then we say that the limit exists or limit is well defined. If f of z equals L when z tends to z0 and L is unique for every path by which z approach z0, then we say that the limit exists or the limit is well defined.